Hello everyone, and welcome to today's chem lesson. Today, we are going to look at those three formulas that we saw in our previous video, the individual gas laws, and as you might guess from the title here, we're going to combine them into one megavoltron gas law. Now, if we take a look at the three formulas that we learned last time, we saw pressure times volume equals pressure times volume, right? The before and the after. We saw volume over temperature equals volume over temperature. And then we also saw pressure over temperature equals pressure over temperature. Now remember again, these ones are our befores and these twos mean our after, right? We're looking at these over a change. Right? If I increase the temperature, what does that do to the volume? If I decrease the pressure, what does that do to the temperature? So on and so forth. And if you look at this, you might be able to see how these get connected together and form one big combined gas law. If you take each of these things and sort of superimpose them onto each other, you're going to get P1V1 over T1 equals P2V2 over T2. And this actually keeps all of our formulas intact, right? If I switch my font back over here, we have pressure times volume equals pressure times volume. That stays intact, right? That's still part of this. That relationship is preserved. We have volume over temperature equals volume over temperature. That relationship is intact and preserved. And we have pressure over temperature equals pressure over temperature, and that relationship is preserved. Right, the combined gas law actually does the work of all three of these gas laws. It's on table T. Right, it's on the back of the reference table, so you never need to memorize any one of these pieces or the combined gas law. And the nice thing is that if you take out any one factor, right, if I take out temperature, I'm left with one of the original gas laws. If I take out pressure, I'm left with one of the original gas laws. If I take out volume, I'm left with one of the original gas laws. And so anytime something is left constant, and if we see a question that says, while temperature is constant, we can just take temperature out and solve the problem accordingly. And so what we're going to do with the rest of our time here is look at a bunch of practice problems. These practice problems are going to use our combined gas law, and we're going to check and see if we can figure out exactly how to solve them. So, without further ado, here's our first practice problem. If our formula is P1V1 over T1 equals P2V2 over T2, take a second and see if you can solve this problem. I'm going to give you about a minute of time here and then go over the problem. let's take a look at this problem. What numbers have they given us? Right, if we look, and I'm going to change my font to something a little lighter, they gave us 115 Kelvin, 60 atmospheres, and in the same sentence, no less. And they also told us an unknown volume. I mean, these three numbers, these three factors, all come into the same sentence, meaning they're all either a before or an after. And they give us a temperature, a pressure, and a volume. In the following sentence, we get another temperature, another pressure, and another volume. So now we've got our pieces. And so if we want to plug in P1 V1 over T1 equals P2 V2 over T2, we're going to plug in our blues for 1 and our greens for 2. Right? Notice how they grouped these things together. They gave you three factors in one sentence, linking them together so you knew which ones were the before and the after. They gave you the others in the starting sentence. So we're going to plug in. We have 60 atmospheres. We have an unknown volume. We have 115 Kelvin. Remember that we always have to plug in Kelvin in a gas law problem. That still applies. So it's a good thing they gave it to us in Kelvin. We don't have to convert. On the other side, we get 30 atmospheres. We get 25 liters. We get 225 Kelvin. And now we need to solve for V1. I've got to get V1 by itself, which means I need to multiply both sides by 115. Alright, multiplying both sides by 115 is going to cancel that out. Divide both sides by 60 atmospheres to cancel this out. And now I've got V1 by itself equal to this setup. When I go through and I solve this, I'm going to look at the numbers 30 times 25 times 115 divided by 225 divided by 60 is going to give me 6.39 liters. Liters, if we take a closer look at our units here, atmospheres are going to cancel out, Kelvin are going to cancel out. The only unit that I'm left with is this liters. So it's the only one that's going to come with me to my final answer. Right, straightforward here. They gave you 5 of your 6 variables and asked you to solve for the missing one. Let's try another. Here's a problem that's going to use the same formula. P1 V1 over T1. P2 V2 over T2. But here, if we look at this question, there's only one number given to you. The only number they give you is the starting volume of 4 liters. The only number they give you is V1. So again, I'm going to give you about a minute to try to see how far you can get in this. Can you find the trick? And then we're going to go over it. So here there are actually a couple of different approaches we can take. If we think about these gas laws individually, right, if we say, well, what happens if I double the pressure to the volume? Right, doubling the pressure is going to affect the volume, right? When one goes up, the other goes down. So if I double the pressure, I'm going to halve the volume. But that doesn't account for the temperature. We know that temperature and volume are directly related. When one goes up, the other goes up. So if one tripled, the other should triple. And so there's actually a couple of different ways we can do this. I'm going to show you first how you plug into the formula to get the right answer. Right, first, we're given STP. Right, they tell us STP, and we know from yesterday, from our last video, that STP is more than just a set of letters. STP is an abbreviation that tells us 1 atmosphere and 273 Kelvin. STP is a set of values that we can find on table A. So I can plug these in, right? A gas starting at STP, it gave me the starting volume, so I actually know P1, 1 ATM, I know V1, 4 liters, and I know T1, 273 Kelvin. It told me what the new pressure is going to be. I doubled my pressure. I'm looking for V2, and it told me temperature tripled. Quick tripling here. It's going to give me 819 Kelvin. And now, all of a sudden, I went from having one number to having 5 numbers. And I can solve this out. After doing some arithmetic to get V2 by itself, right, multiplying both sides by 819, right, making some room. If I multiply both sides by 819, if I divide both sides by 2 atmospheres, I cancel these things out and I get them on the other side. V2 is by itself. I can solve this out and get my very exciting answer of 6 liters. Right, so you can plug into the formula and get an answer. Now, right, people were calling it out in the chat. Actually, just Sylvie was calling it out in the chat. Right, we know how these are going to affect volume. If I double pressure, I'm going to cut my volume in half. So I'm going to go from 4 to 2. But then I triple temperature, and so I'm going to multiply this by 3, right? When one triples, the other triples, right? That's our relationship between temperature and volume. And I'm going to arrive at 6 liters this way as well. Right, there are multiple ways of approaching this problem, but both ways are going to get you to 6 liters. Let's try one more. Here again, we're going to use our PV over T to solve this one out. And again, I'm going to give you about a minute. Make sure you don't fall for any of the tricks. this problem contains a couple of different tricks. But let's just analyze what they've given us in the problem so far. In the first sentence, they give us 3 numbers. Right? They give us a volume, a temperature, and a pressure. And those are the only numbers that they give us. And this is also where our first trick comes into play. If I start plugging in now, and I say 0.89 atmospheres, right? That's the pressure they gave us. 3.75 liters, that's the volume they gave us. As soon as I start writing 5 degrees Celsius, I've already messed this problem up, right? Caught it in the chat, so great. We must use Kelvin. So converting this 35 Celsius to Kelvin is the first thing we need to make sure that we do correctly. It's 308 Kelvin. All right, good. Adding 273 is what we need to do there. But that still only gives us half of our formula filled in. When we look at the next sentence now, if the sample goes to STP, what does the volume become? Okay, so we know we're looking for V2. But we're missing our pressure and our temperature. Right? They didn't give us numbers in the problem. But they say STP. And you can't see it now because I've scribbled all over it, right? But they tell us STP. And we know that STP is a set of values that we can find on table A. We know that that's 1 atmosphere and 273 Kelvin. And so we can take those and plug them in here, and that's our second trick. All right, we don't get stuck here because we know that table A is going to give us these values. Now, look, bam, we've got 5 of our 6 things plugged in for, and we've got 1 that we're going to solve for. We're going to multiply both sides by 273 Kelvin. And that's going to cancel it out. We're going to divide both sides by 1 atmosphere to cancel this out. We're going to get V2 alone equal to this. We're going to plug this into our calculator carefully, and we're going to get 2.96 liters. Liters again because our Kelvin are going to cancel out, and our atmospheres are going to cancel out. Remember, if you get a long decimal, if you get a long answer, the best place to round is the hundredths place, right? So something that's 2.95863129334 and keeps going. Cut it off, keep the hundredths place, and call it a day. Right, so here our answer, 2.96 liters, is where we are going to round our answer to. And that's what we're going to submit, and that's actually the right answer. With that, I'm going to transition us over to our Zoom meeting for questions, comments, concerns, and attendance, and I will see you there.